Today we're doing domains of equations. To find an equation, we're going to do it on a couple of things right now. So we're going to do it on y is equal to the square root of x minus 4. And then we're going to do y is equal to the square root of x plus 4. So now we have two equations which we want to find the domain. When you're doing this, we are not solving. We're not solving for x. We're going to solve at some point, but not for putting 0 in for y and squaring both sides. That's not what we're going to do here. The directions here is saying that we want to find the domain of these functions. So if I'm finding the domain, that means that for every x value, I am going to get an y value back. So something that could be in the domain, for example, and here, if I say something like this, this x value right here is going to have a domain. Let's say that this is 3, then this point right here is going to give me a y value back, and let's just make up a number and say that that is 4. So when I have x is 3, I will get a y value back that is 4. Now, in this case here, if I chose negative 3, then that x value will not give me a y value back because it doesn't hit the actual graph like it did here. So this is in my domain. Sorry. Let me see. This is in my domain. This part is in my domain, but this part is not part of my domain. So from here, we have that the domain is going to be 0 all the way to infinity. Infinity is never included, so we put parentheses, but the 0 is included, and there is the domain of this. So this just means, the domain means the x values that's going to give me a y value back. So if I chose any value between 0 and infinity, I will be able to hit the graph and get a y value back. Over here on the side, not so much. So that's what domain is, but that's looking at it graphically. We want to know the domain of these two functions up here. So when we look at that from those functions, and I'll just rewrite that. So the first function here we're going to deal with is this one here. We're going to start with y equals to the square root of x minus 4. So in order to have a domain there, we need to find out that if I take an x value and I put it in here, I am going to get a y value back. And so the values that when I put in there do not give me a y value back, that's what's not in my domain. So I know that this is the square root and that the index is 2, so it's an even index. If it's an even index, that means that I could have no negative numbers under the radical. So if I don't want any negative numbers, that means that x minus 4 cannot be negative. That means it has to be positive. If x minus 4 is positive in math language, that means that it has to be greater than 0 because any positive number is greater than 0. So that just means that x minus 4 is greater than 0. We did not square both sides. We did not do any of that. We didn't cancel the radical by squaring both sides. All we said was logically that if I want to find the domain of this function, then what's inside cannot be negative. Therefore, it has to be positive. If it's positive, positive in math language means bigger than 0, so greater than 0. So that means that x minus 4 has to be greater than 0. And so when I solve for it, I get x is greater than a positive 4. So that means in interval notation that every x value has to be bigger than 4. So it's 4 to infinity. And in this case, could it equal to 0? And the answer is yes, because I could have the square root of 0 is 0. So then we have a bracket there. Now the difference between this one, now we want to do y equals the square root of x plus 4. Here it's still the same thing. We're going to have whatever inside. We're still finding the domain. The index is still even, so I cannot have a negative on there. And so then I end up with x plus 4 is greater than 0. Now, when we saw, we have it has to be greater than negative 4, so it's from negative 4 all the way to infinity, and could equal 0, so it's a bracket. So those are the two problems. They're pretty basic, but what was inside the radical was linear. That means it was degree 1. That's an easy way to solve when they're linear in degree 1, but they're not always going to be linear or degree 1 on there. What if we had changed this one? Now I'm going to put that in this color. I'm going to take this one right here, but I'm going to change it to x squared minus 4. Now it's no longer a line, no longer linear. Now it's a quadratic, so it forms a parabola with the equation inside. The expression inside is now a quadratic. So that means that I am going to do the same thing that we did before, because it's an even index and it's a square root. That means whatever's inside cannot be negative. It has to be positive. So that means that x squared minus 4 has to be greater than, in this case, it could equal to 0. And so it's still the same step that we did up here. So it's still the first same step right there. The only difference there now is that it's x squared. What this means is that we want positive y values because, again, it's under the radical, and that's what we still want, positive y values. But once we're done with that, now we could just change that, and it's going to be equal to 0. And then we have to do our regular math where we're going to have to factor it or do the square root method. Oops, I got that wrong. So it's minus 2x plus 2 equals to 0. You could do the square root method, and that would have been fine. So we get x is equal to negative 2 and positive 2. But I know that this has to be more than just two answers, because the domain in here, I could put in a lot of numbers in there and still get a positive number out. So what you're going to do here is you're going to graph it. Oops. Let me do the x's. So you're going to graph it negative 2. You're going to graph it to 2. It's going to be included because it's equal to 0. We know it's a parabola because it's concave up. Now remember, we're only graphing what's inside because we just want to know when it's going to be positive. We're not graphing the whole entire thing with the radical. Now x squared minus 4 is this. It's concave up because the leading coefficient is positive. And so it's going through the x-intercepts because that's what these are, the x-intercepts. So now I want to know positive y values. So if this is the x-axis, then these are positive and these are positive. So it's from negative infinity to negative 2. And it's including the negative 2 and then from 2 to infinity. And so that, see how the difference is between this answer and that answer? So the answer changes, and mainly it's because this is now a quadratic and it's not linear. So those two go somehow together. This one here, now let's try this one and see what we get as an answer. So now we're going to change that one, and we're going to change it to y equals square root of x squared plus 4. So looking at this one here, what we do is the same thing. Whatever's under the radical has to be positive here, and it could equal to 0. And then this gives us positive y values. And then we have x squared plus 4 equals to 0. So x squared equals to 4. X is equal to plus or minus. You take the square root of both sides, plus or minus 2. So either one, you could have factored it just like we did earlier, or this is a square root method. So I know it has to be plus or minus 2 there. Oops, I made a mistake, right? So going back on there, because when I went to the other side, what we do get is not right there. We end up with x squared equals to negative 4. Now, can x squared equal negative 4? And anything squared will never give you a negative 4, so you know that that cannot be right. So then I go back to here. This here, I'm never going to, if I were to graph it, I have a complex, since this just means that I do not have any x-intercepts. So there are no x-intercepts because it's not, they're going to be imaginary. So there are no x-intercepts. So that just means that the parabola, because it is concave down, up, because the leading coefficient is positive, that means it's concave up, is just going to look like this. It's not going to cross the x-axis because there are no x-intercepts due to this part, and so it's going to be above. So when do I have positive y values? Well, the answer is I have positive y values always. So this is going to be negative infinity to positive infinity. So I am always going to have positive y values. So while the linear ones were easy to solve, when you have quadratics, that makes a huge difference on how to solve these problems on there. And then if you have, one of the things you need to remember also is that if I have the cube root where the index is going to be 3, that means that I could have, and let me change that to something we know. So negative 8, is that possible? And the answer is yes. Negative 2 times negative 2 times negative 2 equals negative 8. So the answer to this is that the cube root of negative 8 is just negative 2. So this here is the answer to that. So that means that I could have anything under, I could have a positive or a negative under an odd index. And so the domain here, so if I have the cube root of x, the domain there is negative infinity to positive infinity because everything could go in there, the positives and the negatives. Now, if the index is even up here, like we did up here, that cannot happen because you can't have negative numbers in there, and that restricts our domain on there. So this here is showing a few things about the domain. Another thing that you could do is, for example, if I have x squared plus, let's see, I'm just making this up as I go along, 5x minus 6, let's say that I have that. What is the domain to this equation? Well, I know that I cannot have 0 in the denominator. If I cannot have 0 in the denominator, that means that I have to find out what makes it 0. So I have to factor the denominator, and I could get x minus 6, I'm sorry, x plus 6, x minus 1, and that would give me that factor. So that means that x plus 6 times x minus 1 cannot equal to 0 because that would make it undefined in the denominator. So x is negative 6, x is equal to positive 1. So in a line, if I have negative 6 here and I have 1, these are extraneous solutions. So I'm going to have open there, but that's the only thing. They're going to be like vertical asymptotes, these extraneous solutions here. And so if I have that, that means that I still have values. I could choose any x value here. I could substitute it back in there, and I'm going to get a y value back. I could choose x values here, and I could choose x values there. They're all going to give me y values back. So my domain here is going to be negative infinity to negative 6. And then negative 6 to 1, and then 1 to infinity. So they're all going to be not including, so they're all parentheses, and then we put a u on each one. So that this represents that interval, this represents that interval, and that represents that interval. Okay, I think that's a lot. Thanks.